Hello, it's Klaus again from electronics.unmasked. In previous videos I introduced an Excel tool that can be used for planning thermal insulation. The tool has become quite powerful, so I decided to make a step-by-step guide for it. This part is about climate data. From where can we get that data? And what influence has the climate on our energy consumption? A relatively simple Excel sheet has become a fairly powerful tool that you can use to estimate the effect of thermal insulation measures yourself. Of course, it doesn't replace the expert, but you can use it to make a benefit estimate yourself, which doesn't cost you anything. There are already a number of users who have used it successfully to estimate the energy saving of house renovation measures. I presented the tool in previous videos, and I also explained the method I used to calculate the heat fluxes. I will link the two videos in the top right corner. But I just have to admit, the two videos are extensive and the content is a little complicated. At the beginning I honestly didn't expect that you can take so many details into account and make so many interesting predictions with the tool. I feel that I need to create a kind of easy guide that leads you through all the different aspects of the tool. This is now the first episode of a step-by-step guide. It explains the use of the climate data and the effects of the climate. A number of further episodes will follow to cover all aspects and the use of the tool. First, I'll give you an example of where to get the climate data we need for our calculations. Then we do some tests with climate data in different places and look at the effects of extreme temperatures. There are many sources of climate data. What we are looking for is the average day and night temperatures for each month of the year. I'm going to show you an internet site that provides us with the desired climate data at every point on Earth. Let's take Munich in Germany as an example. Then we click on Climate Averages and we get directly the climate data we are looking for. In this case, the data comes from a location in Oberpfaffenhofen, which is about 23 kilometers from Munich. Okay, we can use this data directly for our calculations. The data from this website is very good for starting initial calculations. We will modify them later to reflect interesting scenarios. We now go to the Environment and Targets sheet in our tool. Here we enter our average day and night temperatures for each month. What I'm having here are the monthly values averaged over several years. And therefore, this data will not provide us with any extreme values that may have occurred in our region in recent years. Your local weather service can of course provide you with more precise data for several years and also for your exact location. For example, it might be worth looking at an extremely warm year or an extremely cold year. You can easily change the data yourself accordingly. For now, we will stick with the average day and night temperatures that we have inserted above. What we are still lacking is the temperature in the ground at a depth that corresponds to our basement. We can also find information about this on the internet. In Germany, the temperature in the ground varies between 12 and 16 degrees throughout the year. I use this to estimate the temperature profile over the month and entered it here. In our example, we use a building like there are many in Germany. I will explain later on how to precisely enter the wall areas, window areas, thermal insulation coefficients, etc. Our example building has a basement that is not heated. Then we have a ground floor, a first floor and an attic, all of which are heated or air conditioned. By the way, later we will also learn how to use the tool for houses of other types, because many houses have no basement, a flat roof or maybe only one floor. Air conditioning is not very common in Germany, but we are still looking at it because we naturally want to use the tool worldwide. Even if the typical German travels without taking his home with him, we want to virtually move the house to another country to make some interesting comparisons. By the way, up here you always get the current total energy consumption value and the consumption for heating and air conditioning separately. In Germany you have relatively high consumption for heating and low consumption for air conditioning. Incidentally, the energy efficiency of the example house is not particularly good, with energy consumption of more than 100 kilowatt hours per square meter per year. Actually, you want to have a significantly lower consumption. High energy consumption costs a lot of money. We will see later what can be improved and how we can calculate it all. As promised, we take our not particularly well insulated house and take a virtual trip to Anchorage, so to speak. I have saved the climate data of some regions in a separate sheet. From there, I copy the data from Anchorage and paste it up here. Wow! We have an annual consumption of 192.3 kilowatts per hour per square meter. That's really too much. If we roughly estimate the energy cost from this, then that would be about 192 kilowatt hours by 300 square meters by 10 cents per kilowatt hour, which would result in $5,780 per year just for the heating energy. And we are talking average here. In a particularly cold year, it could probably be significantly more expensive. And we all know that apart from the costs, there are many other good reasons to use less heating energy. So if the house was in Anchorage, then we would have to take action to improve insulation very urgently. Next, we take a virtual trip to New Delhi. We get the climate data for this from my sheet with the example data. Okay, in New Delhi we hardly need to heat, but we would need 54 kilowatt hours per square meter for air conditioning. Here too an improvement of the house would certainly be desirable. Before I now simulate all the places in the world, I would like to ask you which places or regions would be interesting for you. Write me in the comments. And if you subscribe to the channel, you won't miss the answer either. Now we are going back to the Munich region because we want to show other interesting effects. Let's assume that our house is in the mountains at an altitude of over 1000 meters above sea level. There the average temperatures are of course lower, especially the nights in winter are very cold. We reduce the outside temperatures at night in winter by 5 degrees. Okay, at this location in the mountains, our annual energy consumption would increase from 120.8 kilowatt hours to 136.5 kilowatt hours per square meter. Now let's assume that our house is in the middle of the city of Munich. The city center heats up a lot in the summer months, much more than the green surroundings. Let's assume we have a very hot July. In order to simulate this, we insert a temperature of 35 degrees during the day and 30 degrees at night. It's hard to believe, but that's actually sometimes the case in Germany. And yes, during that time air conditioning would be desirable. But 98% of the time we just wouldn't need it. In Germany, air conditioning is almost only worthwhile for the attic floor. And that was the first part of our step-by-step user's guide. We have seen how our tool gives instant feedback whenever the climate parameters are changed. We use an energy efficiency indicator in kilowatt hours per square meter and year to judge the resulting energy consumption. This was the first part of a whole series in which I will explain all features of the tool step by step. There are still a few more parts to come. I always do this using concrete examples to get an immediate idea on the effects on energy consumption immediately. This also provides us with valuable insights that we can use when we want to renovate our house. I hope you had fun. If there are any questions about this first part, please ask in the comments. I will be happy to answer. In the next part, we will see how we can map our own behavior in the tool and how it affects our heating energy consumption. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.